students, welcome back to our chemistry class. Last class we have been discussing about chemical properties. First one we have discussed is metals on reacting with the oxygen. That is, metals on burning in oxygen produces metal oxides. And we discussed that these metallic oxides are basic in nature. Okay, and later class we have also discussed that some metallic oxides like aluminum oxide, zinc oxide and all, they show amphoteric nature where they behave both basic as well as acidic properties they were showing. Now in this class we are going to discuss about what happens when metals react with acids. Children, again another question comes up. What happens when metals react with the acids? You know, some metals like zinc, iron, magnesium, these substances if you take, these reactions are very highly exothermic in nature, where this magnesium or zinc on reacting with the acids, they produce salt, that is ZnCl2 plus hydrogen gas is evolved. So during the formation of ZnCl2, this is a salt produced, salt as well as hydrogen gas is evolved. These reactions are actually highly exothermic in nature. Children, do you know what are exothermic reactions? Exothermic reactions means reactions in which huge amount of heat energy is evolved. So in a reaction, heat energy evolved are called exothermic reactions, and reactions in which heat energy is absorbed and you feel cold if you catch or if you touch the beaker, you will find that it becomes cold, and that is called endothermic reactions. Exothermic reactions are those reactions in which heat energy is evolved or the system becomes hot. Okay. Now among the other metals like sodium, potassium and all, we know sodium and potassium are very highly reactive, so please don't go for the reaction with HCl, because sodium and potassium, even with water, you know, they are very explosive reactions they produce, because hydrogen gas evolved very fast, because very fast reactions they will give. Okay, so don't try to experiment with the sodium and potassium, because sodium and potassium are very highly reactive in nature. Okay, now let's take another example like Mg plus H2SO4. Another acid I am taking. Mg on reacting with the MgSO4, it can produce Mg reacts with H2SO4, it can produce MgSO4 plus H2 gas. All these cases, what happens is hydrogen gas is evolved. Now let's take another acid. This is one of the mineral acid. This is another acid. Let us take HNO3. What happens if HNO3 is reacted with any metal? See, children, you must understand that HNO3 is a very strong oxidizing agent. So what happens? This HNO3 will catch up the hydrogen present or hydrogen formed during the reactions and directly convert this hydrogen into water. So because of that, hydrogen evolution is absolutely not possible when you react instead of any other acids. HNO3, if you are using, HNO3 will not provide you the reactions which HCl and H2SO4 gives. Why? Because HNO3 is a very strong oxidizing agent. Let us say one reaction. Let's take an example of nickel. Nickel on reacting with HNO3. As I mentioned, HNO3 is a very strong oxidizing agent. It will not produce hydrogen. Now let's see what happens during this reaction. It forms NiNO3, NO3 twice, plus NO plus H2O is produced. Children, listen here. Here H2O is produced, but the all other cases, what was actually forming is hydrogen gas is evolved. But when a metal reacted with the HNO3, since HNO3 is a strong oxidizing agent, it will convert substances into either to water, or HNO3 itself will convert into some other gases like nitric oxide. On reacting with the normal acids, metals give salt as well as hydrogen gas. But on reacting with the HNO3, it will not produce hydrogen. Instead of that, it will produce a water molecule and its own different types of oxides are produced, whether it is NO or NO2, depending upon the type of reaction it proceeds. In case of nickel, it forms NO and H2O. Right? Children, some metals like gold, platinum and all are called noble metals. Why? Because they do not react with acids or any other substances. But if you make a combination of hydrochloric acid and HNO3, the combination of HCl and HNO3 in a ratio of 3:1, they produce a substance called aqua regia. Aqua regia in Latin means royal water. Why does it has got this particular name? Because the combination of HCl and HNO3 can even make the solutions of gold. If you put gold into the combination of HCl and HNO3 in 3:1 ratio, you will get aqua regia to that solution. If you add gold, you will get the solution of gold. Okay, so because of that, one thing you have to remember, alone into hydrochloric acid or HNO3, if you add gold, nothing will happen. So the combination of HCl and HNO3 in 3:1 ratio produces a particular solution called aqua regia. Right? Children, now let's see what happens when metals react with solutions of metals. What happens? Metals on reacting with metal salts or other metal salts, we can say. That is, suppose if you take a CuSO4. What is CuSO4? CuSO4 is copper sulfate. You have to make the copper sulfate solution. Into it, you add iron nails or iron powder. You can take iron powder or iron nail. When you add into CuSO4, that is actually we can say metal salt. Copper sulfate is a salt of copper. Okay, now let's do the activity by taking the beaker and add CuSO4 into it. CuSO4 color is a bluish colored substance. What is the color of copper sulfate? Copper sulfate is a bluish colored substance. bluish colored solution. Now if you put some iron powder or iron pieces into it, or you can put an iron nail also into it. Now what happens after some time, this bluish color of copper sulfate changes into some greenish color. Why? Because the CuSO4 has converted it into FeSO4, and Cu will get deposited on the surfaces of these metallic crystals, or we can say into the metallic pieces of iron. Okay, so the brownish colored iron becomes brownish in color because of the deposition of copper, and the copper sulfate solution becomes green in color.
Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take 10 milliliters copper sulfate solution. Tie 2 iron nails with a thread and immerse carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color sulfate solution in test tubes A and B. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. The iron nail became brownish in color, and the blue color of copper sulfate solution fades because iron is displaced by another element, copper, from sulfate solution. Fe plus CuSO4 aqueous gives rise to FeSO4 aqueous plus Cu solid.
So here what we have to understand is, iron is more reactive than copper. So more reactive metal can displace the less reactive metal from the aqueous salt solutions. Clear? Now let's see the metal activity series.
This, my friend, is a song about metals, like the kind you find in your kettles. From most the least reactive, 'cause oxygen's quite attractive to all the metals in the reactivity series. Break it down now. First up, potassium, sodium and calcium, yeah, magnesium and aluminium, just zinc, iron, and lead, hydrogen and copper, next silver, gold and platinum. Break it down now. First up, potassium, sodium and calcium, yeah, magnesium and aluminium, zinc, iron, tin and lead, hydrogen and copper, next silver, gold and platinum. One more time now. First up, potassium, sodium and calcium, yeah, magnesium and aluminium, zinc, iron, tin and lead, hydrogen and copper, next silver, gold and platinum.
So children, from the metal activity series, we have understood that more reactive metal can displace the less reactive metal from their aqueous salt solutions. Clear? So children, so far what we have discussed in chemical properties is, last session we have discussed about metal on reacting with oxygen produces metal oxides. Correct? And these metal oxides are basic in nature. Okay, and today we have learned about metals on reacting with acids. It produces metal salts plus hydrogen gas is evolved, except nitric acid's case. Nitric acid's case, we have seen that nitric acid is not allowing hydrogen to produce because it oxidizes hydrogen to water molecule. Now third we have discussed is metal on reacting with the other metal salts. When it reacts with the other metal salts, then you must remember they must be aqueous than metal salts. They produce more reactive metal. Suppose this is a metal of A, more reactive metal will come, will displace the metal from it, and its salt will produce and the less reactive metal will be displaced. Okay, this is a pure example of displacement reaction. So we can say this is a displacement reaction takes place here. Children, other chemical properties we will be studying in the next module. Thank you and have a nice day.